Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is Cambridge Physics 5054 course, and I'm your teacher, Mariam Rafique. As you know that we are discussing chapter number 3, and the topic today we have to discuss is Newton's laws of motion. Before getting into the core concepts of this chapter, I would like to share some learning outcomes like who was Newton, first law of Newton, or you can say the law of inertia, second law of Newton, recall and use the equation the force is equal to mass time acceleration, and third law of Newton. In physics, students, you know that a force is any interaction that when unopposed will change the motion of an object. So a force can cause an object with mass to change its velocity, which includes to begin moving from a state of rest, that is, you can say, to accelerate. And before knowing about the Newton's laws of motion, I would like to share some background of the scientist, that is Sir Isaac Newton, from 1643 to 1727. He was an English scientist and mathematician, famous for his discovery of the law of gravity, also discovered the 3 laws of motion. Now, why Newton's laws of motion are so important? Because these are the 3 physical laws that stayed together and laid the foundation of classical mechanics, and they describe the relationship between a body and the forces acting upon it and its motion in response to those forces. Now, these are the 3 laws: Newton's first law, second law, and third law. And according to first law, an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. What does this mean? Basically, an object will keep doing what it was doing unless acted on by an unbalanced force. And if the object was sitting still, it will remain stationary. And if it was moving at a constant velocity, it will keep moving. So it takes force to change the motion of an object. Now, what is meant by unbalanced forces? So here is a recall of unbalanced forces, that if the forces on an object are equal and opposite, they are said to be balanced, and the object experiences no change in motion. And if they are not equal and opposite, then the forces are unbalanced and the motion of the object changes. Here are some examples from real life. For example, a soccer ball is sitting at rest and it takes an unbalanced force of a kick to change its motion. And also 2 teams are playing tug of war. They are both exerting equal force on the rope in opposite directions, and this balanced force results in no change of motion. Newton's first law is also called the law of inertia. You have to add these to your notes. Now, what is inertia? Inertia is the tendency of an object to resist changes in its state of motion. The first law states that all objects have inertia. The more mass an object has, the more inertia it has, and the harder it is to change its motion. Now, Newton's first law and U. Don't let this be you. Wear seat belts because of inertia. Objects, including you, resist changes in their motion. And when the car going 80 km/h is stopped by the brick wall, your body keeps moving at 80 km per hour. Here are some more examples from real life. For example, a powerful locomotive begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive and they have a great deal of inertia, and it takes a large force to change their motion. So once they are moving, it takes a large force to stop them. Second, on your way to school, a bug flies into your windshield. Since the bug is so small and it has very little inertia and exerts a very small force on your car, so small that you don't even feel it. Now here is a question that if objects in motion tend to stay in motion, why don't moving objects keep moving forever? And the answer is that things don't keep moving forever because there is almost always an unbalanced force acting upon it. For example, a book sliding across a table slows down and stops because of the force of friction. And if you throw a ball upwards, it will eventually slow down and fall because of the force of gravity. Now in outer space, away from gravity and any sources of friction, a rocket ship launched with a certain speed and direction would keep going in that same direction at that same speed forever. Now we have to see Newton's second law. Force equals mass times acceleration, or we can say that F is equal to ma. Now acceleration here is a measurement of how quickly an object is changing speed. Students, what does F is equal to ma mean? Actually, force is directly proportional to mass and acceleration. Imagine a ball of a certain mass moving at a certain acceleration, and this ball has a certain force. Now imagine that we make the ball twice as big, or you can say double the mass, but keep the acceleration constant. So F is equal to ma says that this new ball has twice the force of the old ball. Now imagine the original ball moving at the twice the original acceleration. So F is equal to ma says that the ball will again have twice the force of the ball at the original acceleration. So F is equal to ma basically means that the force of an object comes from its mass and its acceleration. If you double the mass, you double the force, and if you double the acceleration, you double the force. So doubling the mass and the acceleration of the force 2m into 2a is equal to 4f. So what if you decrease the mass by half, and how much force would the object have now? Please think about it and answer me later. Now F is equal to ma basically means that the force of an object comes from its mass and its acceleration, as we have studied earlier. And something very massive like high mass that's changing speed very slow, like low acceleration, like a glacier, can still have great force. The another example is like something very small, low mass that's changing speed very quickly, like high acceleration, and like a bullet can still have a great force. So something very small, changing speed very slowly, will have a very weak force. Now in the last, Newton's third law, And this states that for every action, there is an equal and opposite reaction. Now, what does this mean? Here is the explanation that for every force acting on an object, there is an equal force acting in the opposite direction. Right now, gravity is pulling you down in your seat, but Newton's third law says that your seat is pushing up against you with equal force. So this is why you are not moving. And there is a balanced force acting on you, gravity pulling down, your seat pushing up. Now students, you have to think about it, that what happens if you are standing on a skateboard or a slippery floor and push against a wall. You slide in the opposite direction away from the wall because you pushed on the wall, but the wall pushed back on you with equal and opposite force. Second, why does it hurt so much when you stub your toe? And when your toe exerts a force on a rock, the rock exerts an equal force back on your toe. The harder you hit your toe against it, the more force the rock exerts back on your toe, and the more your toe hurts. Now here are some vocabulary for this lecture, like inertia, acceleration, velocity, and force. These are the explanation, like inertia is the tendency of an object to resist changes in its state of motion. Acceleration is a change in velocity, or you can say that a measurement of how quickly an object is changing speed and direction. Now, what is velocity? Velocity can be defined as the rate of change of position along a straight line with respect to time. And force is, that the push or pull or strength or energy, you can say. Now, this is the summary of the lecture, or you can say the review of these 3 laws. So thank you so much and good luck.